Gang, we know that we need to measure relative strength of antenna because some antennas are more powerful than others and more powerful in different directions than others. So we need a way to reference that antenna strength. We said one way to do that is using dBi, right? dBi is the tool that we use to measure relative to that perfect isotropic antenna that doesn't really exist in the real world. Well, some vendors think that's ridiculous. And so instead of using dBi, they chose to measure their relative strength of antenna based upon the system of dBd. dBd being the strength compared to a dipole antenna. And that's what we see in this example. This is a picture of what a dipole antenna looks like. This is the antenna. What it's showing is the waveform that's coming out in the vertical and horizontal axis and the way that it's projected. So that's called a dBd measurement. Now, within the dBd scale, everything is still the same. What I mean is 0 to 1, as we're talking about decibels to power, all right? And if you double the power, that's going to add 3 decibels. If you double the power again, that's going to add another 3 decibels. So that would be, for example, 6. If I multiply by 10, so let's say I had a power of 40 relative to that 4 right there, then that would mean, all right, I was already at 6, so I'm going to add 10. So now I'm up to 16 decibels is equal to 40 times the power of one antenna versus another within that dBd scale. All right, that's all we're saying. Life is easy, right? Sure, until you try to compare something based upon that, right, perfect dBi scale, right? That's one antenna. And then I've got this other antenna, and it's measured according to the dBd scale. And I'm trying to say, okay, now which one is actually going to be the more powerful antenna? So let's give an example here. Make sure this makes sense. If I had one system in which I had, let's say, 6 dBd, and the other one was 8 dBi, 2 antennas, right? I'm looking at 2 boxes in the store online. I'm trying to say, okay, which one has the better antenna inside of it to be able to reach far, that has more power, higher amplitude? I have to work with a common denominator. I can't just have 2 abstract systems relative to each other. Fortunately for us, 0 dBd is equal to 2.14 dBi. And so what that means is I could actually simply say this. If you want the dBi, take the dBd, add 2.14. If you want the dBd, take the dBi, subtract 2.14. My mnemonic personally for remembering which way that goes looks a little something like this. I would say that we dB increment. So if I want the dBi, I need to increment the dBd that I already have. If I want the dBd, I dB decrement. I'm going to subtract the dBi value in order to get what I want. So how does this play out in our 6 to 8? Well, I'm going to pick one or the other. So let's say I'm going to stick with dBd. So that means I need to convert dBi to the dBd standard. So I want dBd. I know that's what I want to get. So that means I got to take this and decrement what I already have. So 8 minus 2.14 is going to give me what? That'll be 5.86, right? 5.86 dBd is the same thing as 8 dBi. Okay, so which one's more powerful? Well, they're actually really close, but it turns out that this first box has a little more power to it. And again, remember that relatively small differences, though, are based upon a logarithmic scale. So increasing by even just a few dBd means, well, again, every time you increase by 3 dBd, what have you done? Doubled the power. So don't let relatively small differences make you think that is relatively small difference in that gain of the antenna. It's significant.